Encapsulation is a key principle of object-oriented programming that significantly contributes to the design and maintenance of robust software systems. To understand encapsulation fully, let's delve into its core aspects and benefits. 1. Concept and definition. Encapsulation refers to the practice of bundling data and methods that operate on that data into a single unit, typically a class. The primary goal of encapsulation is to protect the internal state of an object from unintended or harmful interference and misuse. By grouping related data and operations together, encapsulation not only organizes the code but also defines a clear boundary between an object's internal state and its external interface. 2. Data hiding. A fundamental aspect of encapsulation is data hiding. Data hiding means that the internal state of an object is not directly accessible from outside the object. Instead, interaction with the object's state is controlled through public methods. This prevents external code from making arbitrary changes to the object's data, which can lead to inconsistent or invalid states. For example, imagine a class representing a bank account. Without encapsulation, any part of the code could directly modify the account balance. This could lead to errors or security issues, such as unauthorized changes. With encapsulation, you can restrict access to the balance and only allow modifications through well-defined methods, ensuring that all changes adhere to specific rules. 3. Access modifiers. In many programming languages, encapsulation is enforced through access modifiers. These modifiers control the visibility of class members, attributes and methods, and include private. Members marked as private are only accessible within the class itself. They cannot be accessed or modified directly from outside the class. Public. Members marked as public can be accessed and modified from anywhere in the code. These are typically used for methods that provide controlled access to private data. Protected. Members marked as protected are accessible within the class and its subclasses but not from outside the class hierarchy. This allows for controlled inheritance while keeping certain data hidden from external access. 4. Setter and getter methods. To interact with private data, classes often use setter and getter methods. These methods provide a controlled way to access and modify private attributes. Getter methods. These methods retrieve the value of private attributes. For instance, a getBalance method might return the current balance of an account. Setter methods. These methods allow the modification of private attributes, typically including validation to ensure that the new value adheres to certain rules. For example, a setBalance method might ensure that the new balance is not negative before updating it. 5. Benefits of encapsulation. Encapsulation offers several key benefits. Improved maintainability. By hiding the internal details of an object, encapsulation makes it easier to change the internal implementation without affecting other parts of the code. This leads to more maintainable and flexible code. Enhanced security. Encapsulation helps protect the integrity of an object by preventing unauthorized or unintended modifications. This is particularly important for maintaining security and consistency in complex systems. Increased code reusability. Encapsulated objects can be reused across different parts of an application or even in different projects. Since the internal implementation is hidden, the object can be used as a black box, reducing dependencies and improving modularity. Easier debugging and testing. By restricting access to the internal state, Encapsulation makes it easier to test and debug individual components. Any issues can be isolated to the specific class, reducing the complexity of troubleshooting. 6. Real-world analogy. To put encapsulation into perspective, think of it like a smartphone. The smartphone's internal components such as the processor, memory, and battery are encapsulated within the device. You interact with the smartphone through its user interface, like touch screens and buttons. You don't need to understand or access the internal components directly. Instead, you use the provided interface to perform tasks. Similarly, encapsulation in programming allows developers to interact with an object through a well-defined interface while keeping the internal workings hidden.
An example for encapsulation. My revealed code is encapsulation because the property is in the private and it has to access it is security. But now I publish the year. Make it public like this. It in the public. And now I can access it and make change. In the initial, the year is 1949. But now I make a change. Make it 1950 and look at the result. It is 1950. So that for the result and encapsulation, you need to put on your property in the private. So Ctrl Z.